This physics question is about the momentum principle, and specifically, it wants to know about these molecular motors called kinesins, which are located in the cells of the human body, and it wants to know the amount of force a kinesin needs to accelerate an organelle with, this is mass of the organelle, with an initial velocity of 0 micrometers per second to a final velocity of 1 micrometer per second within a time of 10 seconds. So we're looking for the net force. Well, this equation, this is the momentum principle equation, it relates linear momentum, or mass times velocity, with Newton's second law, which rewrites it in terms of momentum as a net force. And we can find this net force by dividing the change in momentum by the change in time. Well, we can further elaborate this equation by writing this out in larger terms. In other words, we know that the change in momentum is equal to the final momentum minus the initial momentum divided by time. And we can further write that out by saying momentum is equal to the mass times the velocity final minus the mass times velocity initial divided by time. And so this equation, once we plug everything in, equals the force that we are looking for, that these kinesins need to push on these organelles. So once we plug these values in, we plug the mass of the organelle here, and we multiply it times the velocity final. And so we subtract the initial velocity times the mass here, which this term goes to 0. And we divide that by our 10 microseconds. And we end up with 1 times 10 to the minus 18 newtons that these kinesins need to be pushing on those organelles.